Hi, welcome to the fourth video tutorial for the Glacier Image Velocimetry or GIV toolbox. My name is Max van Veek de Vries. I'm going to be talking quickly through the small amount of pre-processing that you'll want to apply to the images prior to running them through GIV and the overall file structure that you will need to successfully run the model. And I'm just going to point out a couple of common pitfalls. If something goes wrong, it may well be one of these things. So the main steps that you'll need to take prior to pressing run on the GIV model are to create a new folder and to place all of your satellite images, whether they're PNGs, JPGs, or GeoTIFFs, in that folder. You're going to want to rename all of the images to the format year, month, day. For example, 2020-0122 for this 22nd of January 2020. I'll show you in a moment that I've included in the description a bulk renaming script, which can do this automatically for however many images you have. This can save a fair amount of time if you have 100 or more images. And finally, you're going to want to create a save image. You're going to want to create an ice mask. And in some cases, you're going to want to create a stable ground mask that will be used for correcting for systematic georeferencing errors. Now, I'll show you exactly how these things look in a moment. But first, to just touch on when things go wrong, it's often that some of the files have been named incorrectly. If the files aren't named in the year, month, day format, they will not be read correctly, as GIV does read the temporal information from the file names. So for example, if you name it the other way around in like day, month, year, then it will be incorrectly read out. And your run will fail. So be careful about that. Something that can cause it to fail is if you combine multiple data sets in the same folder. For example, if you put the satellite images from 2 different glaciers in the same folder, then GIV will attempt to run all of them and will not produce meaningful results because of that. So be careful about that. Something that can go wrong with your Glacier mask is if you don't make it out of pure white pixels. So they need to be RGB 255, all of them, which you can get by automatically painting over it in Illustrator or in MS Paint or in any similar program. But if you accidentally make them very light gray, then they will not be recognized as an ice mask, and you will calculate no velocities. And a common issue with a stable ground mask is introducing a lot of noise into the data set by accidentally including water in the stable ground mask, because water naturally, there aren't persistent features on water, so it can't be tracked. However, if you include water in your stable mask, you often risk biasing the results towards whatever noise was in that water. So just to have a look at a folder, here we've got some images from Perito Moreno Glacier again that you may remember from the first video. And so I've downloaded 4 GeoTIFFs of the glacier. These are the actual images that we're going to use. And I've also downloaded 1 JPG image of the glacier that I've duplicated to create a save image. It wants to be called exactly this, with lowercase letters, save image. We need one called mask, which is going to be our ice mask. And we need one called stable, which is going to be the stable ground. And essentially what the stable ground mask does is the velocity of the stable ground areas will be subtracted from the whole image to correct for any systematic errors. So the first thing you're going to want to do is you're going to want to rename these. I downloaded them from Sentinel-EO browser, so they have this fairly long name that GIV can't understand. In this case, there's only 4 of them, so I could manually rename them, but I can also use an automatic bulk renaming script, which I have included in the description, the GitHub link to it. So feel free to download it. If you don't have access to MATLAB, then I'm afraid I can't help you with this. You might have to do it manually, but it doesn't take too long anyway. But basically the format of this bulk rename script, you just write bulk rename, open a bracket, then you're going to want to copy the path that these images are in. So the first thing I'm going to say is you want to make sure there's nothing else in there. So I'm going to remove those images, remove the JPG images from there for now. You want to have a folder with only the images you want to rename. So then I'm going to put it, and you want a single quote around the path. And then the second option is going to be EOB, because these were downloaded from Sentinel-EO browser. So this is their name currently, and then I'm going to run this, and it's going to run instantly, and they've all been renamed to the format year, month, day, day. And if I'd had 100 images there, it could still be renamed. So that's quite convenient. I'll just move my masks back in there. The save image will leave as is. That just is used for plotting figures. The mask is what I'm going to edit right now, just to show you what we want to do with this. I'm going to open it with MS Paint, which I've found to be the most convenient way to do it on Windows. And essentially what we want to do is paint it in pure white. And this is going to be pure white here. So we're going to want to paint over the glacier, or the glacier plus any surrounding areas, in white. So what we could do is carefully sketch out the glacier outline. But in a lot of cases, actually having the velocity information from the surrounding bedrock is interesting as well, to visually evaluate the noise levels. So often what I just do is draw virtually the entire image in white. Although if you want to go for maximum computational efficiency, just carefully sketch out the margins of the glacier. And then for your stable ground image, however, you're going to want to be a lot more careful. You're going to similarly draw a pure white mask everywhere where you have stable bedrock, or rather just stable ground that isn't moving. But a common error would be, for example, just drawing the inverse of the ice mask and including the lake. And that would be a mistake, because often there will be like icebergs that will be tracked. There'll be some very high velocity noise in the lake, and then it will automatically correct using that data as well, which can cause a lot more noise in the data set. So just draw it over the bedrock. Make sure you don't include any of the glacier as well, otherwise you will correct for the velocity of the glacier in that portion. And you don't need to paint all of the bedrock. You just want to paint enough that you're getting a representative sample. And ideally, you want to include bedrock of different aspects, sloping in different directions, because there can be distortions that depend on the direction as well. So ideally, getting a range of aspects is useful. So here, this would be a suitable stable ground mask. Stable ground masks are generally the most valuable in slow-moving glaciers, for which the georeferencing errors are actually significant. In Perito Moreno, it's moving so fast that this isn't a major issue. But if you're, say, looking at much smaller valley glaciers, this can be a very important step. Okay, those are the main pre-processing steps. So long as you have this file structure, you have your images named to year, month, day. You have your mask, you have your stable, your save image, and if you need it, you have your stable ground image. You're all set to run. In the next video, we're going to start looking at the GIV inputs. Thanks.